Hello everyone. This lecture is about the Raman amplifier. So in last video we have seen different what is the application of optical amplifier, what are the different components and what are the different configuration, and we have also discussed about the EDFA. EDFA is a type of the optical amplifier. Now we have to discuss about the Raman amplifier. So basically this Fiber Raman amplifier is based on the principle of SRS. This is SRS. So what is SRS? This is the stimulated Raman scattering. SRS is stimulated Raman scattering. So fiber Raman amplifier is based on the principle of SRS. So in this, basically this is based on the stimulated emissions. And in this there is a no need of doping, and it will provide the wide application wavelength region, and that can be freely set by the wavelength of the excitation light. So from where we are getting this excitation light? From the sources, pump sources. So now we will discuss in detail about this Raman amplifier. So this is the basic diagram representing the Raman optical fiber. Here you can see this is the optical fiber, and here in this optical fiber there is a no doping. Whereas in case of EDFA we have doped this optical fiber using Arabian iron. But here this optical fiber is not doped. This the core is made up of the usual optical fiber materials. Here we are using pump lasers for the stimulating SRS effect. Basically, this is based on the stimulated Raman scattering. So here what we are doing, we are inserting a photon that excites the electron and goes into the vibrational state. So what is the meaning, what we are particularly we are doing? So in this there is a interaction of optical energy with the vibrational modes of the lattice structure of this material. So here what is happening here? The There is an interaction of the optical energy. Whatever photons are given to this optical fiber, that correspond to the optical energy field, and that optical energy field is interact with the vibrational modes of the lattice structure of the material. So whatever material we are using this, so both are interacting. As a result, SRS effect is produced. So here the stimulated emission occur when the electron de-excite to the vibrational state of the glass molecule. Here the material is used is glass. So this optical fiber is made up of glass molecule. So when there is an interaction, the stimulated emission occur. So basically this optical amplifier can be used in two ways, lump type and distributed type. So in LRA type, the gain optical fiber has fiber gain media of 10 kilometer, and it requires very high power of pump laser, and it produces the high optical output power. Whereas in case of DRA, the strength of power laser is hundreds of megawatts. So these are the two configuration of this Raman amplifier, LRA and the DRA. This is the basic comparison between the EDFA and the Raman amplifier. The basic difference lie in the working principle and the power amplification band, in which particular band this is working. So in case of EDFA, this is the band, and Raman amplifier worked for the all wavelength, and it depends on the pump power, the noise figure, gain, and the cost. So this is the comparative chart of the EDFA and the Raman amplifier. Now next type is a SOA, semiconductor optical amplifier, and as the name is semiconductor optical amplifier. Here we are using the semiconductor material for the designing of this SOA. So this is for your additional study, and we will cover this in next topic in next video.